I'm going to be finishing up Chapter 17, Section 4 in this video. In the Part 1 that you guys did last week, we talked about finding volume of three-dimensional shapes. So in this video, we're going to focus more on finding area of them, and there's actually two different types of area that we could actually find, and we'll get into both of those. So we're going to first start off with prisms and cylinders. Now these are the two types of area that I was talking about. So the first one is called lateral surface area, or LSA, and that's when you find the area of its sides only. Total surface area, or TSA, is when you find the area of all the sides plus the area of its base or its bases. So for example, if you're looking at a cylinder, remember a cylinder has two circles as its bases, and it's got a curved edge that goes all the way around it. So lateral surface area would just be finding the curved area that goes around the shape, and then the total surface area would be adding in the two circle bases. For lateral surface area, the equation is P times H. P is going to be the perimeter of your base shape. H is going to be the height of the 3D figure. And then for total surface area, it's that PH, so it's the lateral, plus 2 times B. And the P is still the perimeter of the base. H is still the height of the 3D figure. Capital B is going to be the area of the base. So you just have to add in that extra piece. Let's take a look at some examples. So I want to find the lateral surface area of a rectangular shipping carton that measures 24 inches in length, 12 inches in width, and 20 inches in height. So you can see the picture here has those dimensions labeled for you. So lateral surface area would be your P times H. So we have to find the perimeter of the base shape. Now since this is a rectangular shipping carton, that means it would be a rectangular prism. So the base shape is going to be a rectangle. To find the perimeter of a rectangle, you do 2 times the length plus 2 times the width. So you can see how I've replaced P with that formula, and then times H, which would be the height of the prism. Remember, height of prisms or like cylinders would be the distance between the two bases. So plugging in the information from the picture, we're going to take 2 times 24 plus 2 times 12. So those are the two numbers down here, 24 and 12, that go along the rectangle. And then the 20 right here, that is on the height of this shape. So that would be the distance, like up here's the top base rectangle, and this one down here is the other one. So you plug that in, evaluate, so we get 72 times 20. So we end up with 1,440, and this would be inches squared. Since we're back to area, make sure that your labels are the measurement that they're using, and then it's just squared. Another example here. How many square centimeters of sheet metal are required to manufacture a can that has a radius of 4.5 centimeters and a height of 9 centimeters? So, total surface area would be PH plus 2B. And I know that they're wanting total surface area because they want to know how much is needed to create the entire can. So that would be the curved edge and the two bases on top. For a cylinder, remember for perimeter, that would be 2 pi r, or you could do pi times diameter. I'm using 2 pi r because they do give me the radius, and then times h. And then the area of a base would be pi r squared for a circle, so we're taking 2 times pi r squared. So plugging in 2 times pi, radius is 4.5, height of the cylinder is 9, and then plus 2 times pi times 4.5 squared. Evaluating that, we get 381.70 centimeters squared. Again, you're going to want to use a calculator for that. If your calculator does not have a pi button, you can just use 3.14, and you'll get an answer very close to what I have. Next one here, find the total surface area of the triangular prism. So just take a note that this time your base shape is a triangle. So when you're finding the perimeter of the base and the area of the base, you'll have to think about a triangle shape, like what are those formulas? The height of this prism is at 15 centimeters because that's the distance between the two triangle bases. So total surface area is that PH plus 2B. To find the perimeter of a triangle, you add up the three sides. So we saw that as A plus B plus C. All of these formulas are from a previous section that we've already done on two-dimensional figures. I believe that was section 2 or 3. So if you don't remember some of those, I would go back to one of those previous videos if you didn't write anything down in order to use those formulas. So A plus B plus C would be the perimeter of the triangle, and then times the height of the prism, plus 2, now area of the base is a triangle, so area of a triangle is a half times base times height. Now don't get this height here confused with height for the prism. They're two different things. The height inside the parentheses here by the 1/2 and the B, that is talking about the height of the triangular prism, which is this 2.6, just the triangle shape there. So the 3 side lengths of the triangle are 3, 3, 3. So we put those in. Height of the prism is 15. That's from here. Plus the 2, 1/2. The base of the triangle would be 3, and the height of the triangle would be 2.6. So that's where I got all those numbers from. Evaluating, we get 135 plus 7.8. So we get 142.8 centimeters squared. Getting into spheres and cones now. Again, the lateral and the total surface area is talking about the same type of things that they were with prisms and cylinders. For a sphere, spheres only have total surface area. They don't have lateral surface area because a sphere is just a continually curved surface. Okay, so there's not going to be a separation between a base and the sides because there is no difference there. It's all just one big piece. That formula is 4 pi times r squared. Now for a cone, we do have 2 different formulas here, and these formulas take in this new height that we haven't talked a whole lot about, which is called the slant height. If you think about a cone or a pyramid shape, if you look at the sides, they all come down from that vertex or that apex point, and as they come down, it's slanted. So that is called the slant height. Now there's also the vertical height, which is inside, and that we used a lot more for volume. For lateral surface area and total surface area, we're going to use the slant height. So the formula for LSA is pi rs, and then TSA, total surface area, is pi rs, that lateral, plus pi r squared. And r is the radius of your cone, s is that slant height. So you're going to be looking for that piece that's on the outside of the cone. So we want to find the total surface area of a sphere that has a diameter of 90 centimeters. So we're using the formula 4 pi r squared. Now since they give us the diameter of 90, we'll have to cut that in half for the radius. So we put in 45 for r. So we get 25,447 centimeters squared. Okay, for this next one, we want to find the lateral surface area and the total surface area of a cone that has a diameter of 8 centimeters, height of 6 centimeters, and slant height of 7 centimeters. Now remember, for cones, we'll be using the radius, so we will have to cut that diameter of 8 in half to 4. And they are throwing in the regular height here, probably to try to trick you. So make sure that you just kind of disregard the height of 6, because you want to use the slant height of 7. So for lateral surface area, we have the equation pi rs. So we're going to do pi times 4, 4 being the radius, times s, that slant height. So we get 87.96 centimeters squared. For total surface area, we're going to do that lateral, pi rs, and then add on the pi r squared. Now I'm just going to grab the 87.96 and drop that down in that pi rs portion. You could easily re-plug in pi times 4 times 7, but you don't have to repeat that if you already know the answer or you have it. You can just use that. So I'm just adding on to that number then, pi times 4 squared. And so I get 138.23 centimeters squared. Okay, your homework assignment can be found on the homework website. There's a link to a Google Doc there that you guys can make a copy of and then submit your assignments back to me via email. If you have any questions, please let me know and I will help you out.